Okay, it is now time for us to add in the commands required to create nodes in our scene. At this point in time, all we have are commands that allow us to do things like clear the screen, exit, etc. So, what kind of things do we need to be able to create? Well, if you think back to when we first introduced the challenge of Knowledge Review 7, we had said that the command line interface needed to support the commands required to create a sphere and a light. And those commands were simply sphere and light. Now, we could go in here and create individual commands for these items, but it would be a lot nicer if we had a single create command, and inside that create command, we were able to determine exactly what kind of item it was that you wanted to create, and then create the item. Now, at this point, we've seen that when registering a command, all we needed to do was basically call the constructor and send the text, the name of the command that we want it to bind to the actual object itself. So in this particular case, we've kept our names very similar to the command itself. Like in this case here where I've just underlined the word clear, we have bound the word clear to the command clear. But if you think about it, we do have an ability to bind multiple text names to the same command, right, Logan?
Right. I mean, it still involves making multiple instances of that command, but there's nothing stopping us from making a creation command bound to sphere, and then another creation command bound to light.
That's right. So if you wanted to look at it like this, what we could basically have would be, let's say, actually we can do this just a little bit better than that. So let's say sphere, let's say light. Now over here, this is just a mock-up. We have our command create. And inside of command create, inside of the process method, we could basically do a switch. And we can switch on that argument 0, so basically on the command. So if we had bound sphere to create or light to create, basically as we get into our command create class, then we can switch upon that argument 0. I'll just put arg 0. And then we could say case. We had a sphere, then we could do what's necessary. Case, we had a light. Once again, do what's necessary. And do what's necessary is basically a one-liner, and you'll see that in just a minute. And because of this, we can use the switch case without it becoming convoluted with a whole bunch of code in there that's different with each item that needs to be created. Right, Logan?
Right. I mean, the line is going to look almost identical. The only things that change within it, actually the only thing that changes within it, is what case we're looking for and what type of geometry we're creating, what type of shape node we're creating.
That's right.
So it's another case where it just looks like a text association with a type. That's really the only purpose of the line.
So in the end, the command create class will have a switch in it that will basically switch between different types of commands that we have set up to respond as create commands. Does that make sense?
Right. It makes it set up to where the create command is kind of like a smart command.
Yeah.
It can be invoked, and it is actually responsive to what textual command invoked it. It can look at that textual command and then decide how it should operate. It can actually look and say, were we called as a light, were we called as a sphere, were we called as something else? And the idea behind this, while that in itself is rather cool that the command itself can look at the command that invoked it, it also means that we have less redundant code through our classes, because if we didn't wrap all this functionality into a single create command, we would have a scenario where the sphere command and the light command would be two separate classes, even though their internal code was identical, except for a little piece of text and then a type.
Exactly.
Everything else would be identical.
So what I'm doing right here is I'm just giving a quick example of what it would look like. So here we are creating a new command create instance of the command create class, and we'll bind it to the text sphere. And then we could turn right around and use this exact same line where we're doing a new command create. So we're doing a second instance of the command create class, and we bind it to the text light. Now what's happening is we are relying on this switch to make sure the specific item that we are looking to create gets handled appropriately. Okay, that's the important thing to understand here. So yes, we are making multiple instances of the same class, but there's very, very little overhead that is involved here. We're not dealing with millions of commands, so we're not hurting ourselves in any way. And in this particular case, this is going to work out well. Later on, when we show you some other very cool things that can be done in C#, we'll take a look at some more efficient ways of doing this kind of stuff. But for now, this is going to work perfect with what we have seen. So in the end, just keep in mind, we are creating multiple instances of the command create class. Okay, so Logan, with that, let's go ahead and jump on over to Visual Studio.
And let's begin the command create.
Okay.
So I'll jump to the commands folder, add a new item, and this will once again be using the command template. So we'll call this command create. And that gives us our skeleton code. Now, there's a few things we need to do. We've talked about how we need to have this command respond to different actual commands so that we can have multiple bindings.
Mm-hmm.
And there's another thing that would be nice, another feature that would be very convenient to have with the create command, and that would be the ability to specify a name for the new node that is being created, as well as specifying a default mode so that if no name is given, it simply uses the type. For example, if we're responding to sphere as a create command, we have two options: to type in sphere and then a name, so we could do sphere my sphere, or to just type the word sphere and let it create sphere, or sphere 2, or sphere 3, because if you remember, we have the automatic naming validation, so we don't have to worry about that. We can just take in the actual command, or allow a command to be specified. So let's take a look at setting some of that up. The first thing we'll need is a string to accommodate this name. So we'll have a string for node name. Alright, and let's see, let's turn around. Now we need to initialize it, but I'm going to initialize it inside of an if-else.
Okay.
Because again, we have the possibility of having a specified name or a default name. So we're going to do a check and see how many arguments we have. If we have more than one argument, then we can use that given argument as the name. Otherwise, we have to use the command.
Okay. So, and once again, if you guys want to do some fancy error checking, in this particular case, think about it. You're only allowed to have a maximum of 2 things inside the arguments array. The command itself, say sphere, and then the parameter, in this particular case, a second item would be what? The name that you're hoping to create your sphere as. So sphere being the argument or the parameter.
Right. So if we have any argument after the command, we use it.
Okay.
Otherwise, we have to use the command itself. So we'll say that node name is equal to argument 0. So if there is indeed a name parameter or use name argument, use it. If not, use the typed command for the name.
Now, of course, this doesn't guarantee that the node that's going to be created is going to have that name. But remember, we've already got the naming system set up when we created the DAG engine, such that if you say, create a sphere named mySphere, if mySphere already exists, it'll be called mySphere2. So that's very convenient. That's already in place and has been proven to be quite stable.
Right, so we can just come up with a desired name and then allow the engine to handle it from there on out.
Exactly. So now we're ready to go ahead and set up our switch so that we can switch based on what kind of item it is you're wanting to create. So we will switch based on arguments sub-0. So once again, it's like we're switching on the command.
Exactly. So we can set up the switch and then put in some cases. The first case will be for sphere.
Let's go and break this up over multiple lines, and we'll pull it back to a single line just to show them how it's convenient.
Sure. So just to make this look more familiar, we'll set up a case for sphere, jump down a line, and now what do we want to actually do? We'll do this in a simple way, and we'll deal with output here in a minute. We can just leave the output default for now. What we want to actually have happen if sphere was the command is to make a new geometry node with the given or with the desired node name, since we've already figured out what the name should be. And really, that's all that needs to be done as an action.
Okay.
So, I mean, we have that case. Now, of course, we need the break for the switch to function properly. So there we have a given case.
Okay.
Do you want to go ahead and throw a light in?
Yeah, sure. Why not? Because we'll clean all this up just a second so that it looks very streamlined.
Sure. But to show what a second case would look like, I could copy and paste this case and simply change it to light. And the type of node is going to be a light node.
All right.
And that's all that changes line by line.
Now you can go ahead and build real quick, make sure everything builds fine. Let's go ahead and jump over to our command manager and register both the sphere and the light commands. We can get some very simple execution taking place. Then we can come back and expand on this switch case just a little bit.
All right. Let me load the command manager back up. And then let's see. This is going to be an editing command.
Or a creation command.
Oh, yeah, exactly. We're not into editing yet, so this is a creation. Whoops. Creation commands. And once again, I'll be lazy and copy an existing line. Only now we're changing this to a command create for the type of command, and we're going to bind it to sphere.
Okay.
Now, in order to make both sphere and light work, I'll copy this line again. Only in this case, the only thing I'll change is the text. So that way, the text sphere invokes a command create, and the text light invokes a command create. It's just that the command create is smart enough to decide what to do based on sphere and light.
Very nice. So let's go ahead and build and execute. All right, so let's go ahead and now type ls. Okay, so that's what we got. Now let's see if we can create a sphere. And ls. Ooh, we now have sphere too. Now let's create a sphere again, but let's call it my ball.
Sphere, my...
Back up a couple more.
There we go.
There we go. Enter. And ls. Ooh, look at that. We now have my ball, and the shape node is called my ball shape. Fantastic. Now let's see if we can create a light.
So a light, list, and we have a light.
And let's go ahead and try creating a light with a specified name, like light spotlight. All right, fantastic. So we can see that this is working really well. But it would be nice if we got some input sent back out, like result spotlight, or whatever the name ended up being. So I may have asked for the system to create a node called my ball, but perhaps my ball was already taken. It would have been nice to have result my ball 2 so that I would visually see that, oh, okay, the item I just created, it's not named exactly what I wanted. It has this number appended to the end of it.
Right, without having to invoke a list to see what the result was.
Precisely. So let's go ahead and take a look at how we can enhance our command just a bit.
All right. So what would be very convenient is to utilize the output to show what the result was from either of these. So what we could do is we want to access the name that we actually got. We can't use the name that we're feeding in because we might feed in something like my ball, regardless of whether or not a my ball node already exists. Instead, what we need to do is after this is created, turn around and look at its name.
That's right. But we don't really want to hold a reference to it.
No, we
just
don't want
to pull its name back out.
Right, because this is all just all in one line.
That's right.
Very quickly. And so what's cool is after the creation, we can actually reference that instance by simply using dot, and we can gain access to that. So we don't actually have to store a reference. We can just use the one we're creating here, which means we have name available. So what's going to happen is after we create a new geometry node, we then have access to its name, which if we wanted to, we could store that in output. So output is equal to the new geometry node's name. Okay. So even though we're feeding in a desired name, we then turn around and look at the actual name.
Okay.
We store that in output.
Okay.
And we can do the same thing for the light node, because we want the same functionality there. So dot name. So if we build, everything still works. We already have the output system set up from the template. So we should be able to run and to make this a little...
Sure, go ahead and put result. Use a capital R in there for me.
Right. Instead of just showing output, because the result would then be, we would type in light and we'd just say light.
Right.
What would be nice is to see the actual word result in front of the output. So we could do something like return result and then append the output to that.
Okay. Let's go ahead and run it real quick.
So if we make a light, result.
That's what I thought you'd get. What we need to do is go ahead and change the name to dot transform node dot name.
I wasn't even thinking when I was looking at the node. I was forgetting the fact that, well, think about it. What is a geometry node? A geometry node is a shape node.
That's right.
So new is obviously going to return a shape node, actually a geometry node.
I was already on this. I was expecting it, but I wanted to kind of wait just so that they could see that you are indeed accessing the shape node's name, because that is very cool and can become very useful later. So all you need to do, though, is say dot transform node.
Because transform node is, again, something else we have access to from a shape node.
That's right.
Now, if we're looking at a transform node, what does it have? Well, it's still a node. It has a name.
Beautiful.
So if we want to access the proper name, the transform name, the name of what we actually created. Now let's try this. Light, result light. Okay. Light again. Result light 2.
Fantastic.
Or sphere, my ball.
Sphere? Yeah.
There we go. So result, my ball. If we run it again, my ball 2, 3, 4, so on. And if we do an ls, now we see we have a lot of stuff. But the result makes it very easy to see what just happened when the create command is used.
Exactly. So just remember, the big thing that's going on here, because this is somewhat unique what we have done, is inside the command manager we have instantiated the command create class 2 times. But we have, with the 2 instantiations, set the name of each command differently. So we have a sphere command create and a light command create. And then, so that's basically just binding that text to that particular command. And then when we loop through and we find sphere or find light, when we are inside of our process command and we call upon the actual process in the create command or the command create itself, then we're relying on the switch here to switch to the appropriate item that we're looking to create. Okay, that's the key thing to remember. And that's pretty much it. Logan, is there anything else you'd like to add to this?
Me personally, just a more of an aesthetic adjustment I'd like to do.
Yep, I know where you're going.
I would actually rather put this all on one line for each different type that can be created. So that's taking the output and creation, putting it on the same line as the case and the same line as the break.
Right.
What that does, now, of course, this all comes down to a matter of personal preference. You may prefer not having these lines scroll out past the screen of the buffer. But at the same time, if it's all in one line, it actually makes it easier to copy this and make new things. For example, what if we wanted to make it register a box command? With these cases all in one line, it's more convenient to copy and paste that line so it can respond to the box command and create a geometry node. We don't have anything specific for sphere and box, but still, we could make it respond to box. If there was an actual box node, then the only other change I would have to change is this type.
So
that's only 2 changes per line. While the rest of the code does kind of go off screen, it's the part of the code that we don't change. So my personal preference in this case is to put everything all in one line so that if you ever have a lot of things that this responds to, there's actually fewer actual lines in the class.
Exactly. Now, please keep in mind, let's go ahead and walk on over to the command manager. You need to register that new command.
Right,
even though it's not a new command class, it still acts as a new command, so we need to bind box to the command create.
Right, because obviously if we run really quick and say box, it's an invalid command. Invalid command at the command processing level, because box has not been registered as a command. So all we need to do is make a new, or copy a creation of a create command, have it respond to the text box, run, and we can create boxes.
There you go. Okay, and is that pretty much everything you want to add in, Logan?
Yeah, I think that wraps it up.
Okay, so with that, that concludes this video. Thanks a lot.